with locking and also with monitors as uh, indicated in the slide pack, which you've probably just viewed before this one. So there are a number of problems in this particular pack. The first one is to actually use the bank account as given on the website and now write a wrapper class that will do all of the synchronization in that particular class. This is really to show you that the adaptation mechanism, which is again described in the slide pack, can actually take an off-the-shelf component here, bank account in quotes, and add synchronization to it so that thread safety can be a feature of something you write where you're actually using behavior from somewhere else. The second bullet on this particular slide refers to the now using the wait notify in order to have a withdrawal wait until the appropriate level of funds is actually in the account. Now this is essentially in the slide pack, so it's more of a test of you actually finding material in the slide pack than anything else. But what you want to be able to do is to ensure that regardless of the order in which deposits and withdrawals occur, all of the withdrawals will ultimately be processed. Again, assuming that you deposit enough money, otherwise one of the threads or more of the withdrawal customers will actually wait forever. So for the remainder of the problems, what you're going to actually do is to create mutexes and various forms of them with various different properties. So what I want you to do is to create that the facility to lock something and do it in a reentrant way. And in order to do that, you're going to want to implement acquire release. And you could use Java util concurrent to do this, but I prefer that you use wait and notify now to become familiar with what these things actually do for you. So the idea is on the acquire, you're going to test whether or not the lock is currently in use. And if it's not in use, then you acquire it. You set the property to be true. Otherwise, you have to wait. And then when somebody releases the lock, then you just notify. But you only now notify one thread rather than notify everyone. The bulk reentrant class just adds a little bit more state now, because what you want to be able to do is if after n attempts to acquire the lock, it still hasn't acquired it, we then just throw an exception. We give up trying to acquire it. So really that's a change inside of the acquire method in order to keep some measure of state associated with the lock itself. And again, I really want you to use notify wait as opposed to using Java util concurrent. The reference to Java util concurrent there is really so you can find that these things have already been written for you. Now create another class that will only allow the lock to be held for a certain period of time. The idea here is that you do not wish an application to suffer from a liveness problem by somebody actually dying or getting into a state where they can't proceed themselves. So you actually unlock something automatically if it's been held for too long. Problem 5 is just a trick question, and if you don't understand it, talk to me. Now, problem 6 is a variation on the problem earlier, wherein the idea is that the lock is not reentrant. Java locks built into the system are reentrant, namely a thread which already has the lock can re-enter a method so that recursive behavior is easily implemented. But there are situations when non-reentrant locks are required. And so, excuse me, here the idea is to provide that. And in a way, it's simpler to provide non-reentrancy than it is reentrancy, because in the reentrant case, you have to look at whether the lock is currently in use, and if it's in use, is the current thread the same as the one that used it or acquired it in the first case? So problem 6 is simpler than question problem 2. Finally, problem 7 is really completely optional. What you could do is rewrite now your bank account to use method adapters. So you create a superclass that's going to call the bank account code, but now it's going to explicitly put mutexes before and after. So it's going to acquire the mutex, and then it's going to release it afterwards using this, try finally kind of mechanism that you see in the notes. That's optional because there's a lot in this particular slide pack, but it's good to test your understanding by putting all of this stuff together, and you'll have to do it anyway.